questions. I already told the priority to decide which is more stable, which is less stable. So based on that, we can simply decide the stability of the compounds. Okay. The next one is that is for electronic effects. We have seen resonance Vaishnav yesterday. Vivek, good evening. Today we are going to see like inductive effect, electromagnetic effect, and hyperconjugation. Yeah, Manjari, fine. Yeah, Avinash, good evening. Continuation of GOC part, yes. So, any doubts are there regarding yesterday's class? If any doubts you have, you can ask. If you don't have any doubt, then we'll move to the next concept, hyperconjugation. Hyperconjugation. After the resonance. All these concepts are very, very important, guys. It's not about only one question or two questions. To understand remaining organic chemistry, these are very, very important. So that's why better to give a little more focus towards the GOC. So by having command over the GOC, then only we can learn the remaining organic chemistry more effectively. Yes, sir. Fine. Hyperconjugation. It is simply, right, if you go for the definition, delocalization of, yesterday we have seen delocalization of pi electrons is nothing but resonance. But it is the delocalization of alpha CH sigma electrons. Delocalization of alpha CH sigma electrons is nothing but hyperconjugation. We know what is alpha carbon. For the functional group or a double bond or a triple bond, whatever it is, the adjacent carbon is called as alpha carbon. So for that hydrogen is there, that hydrogen is nothing but alpha hydrogen. Yes or no? The hydrogen which is attached to the alpha carbon is nothing but alpha hydrogen gas. Okay. So this is what we have seen. See there, delocalization of a CH. Now we'll decide here something else. First one, sigma pi star overlapping in this. See in what way it will happen. Sigma pi star overlapping. Yeah, I'm taking this kind of compound, CH, H, and pi star, no, C, H, double bond C, H and H like that. Okay. Now this is the double bond functional group and this is the alpha carbon. Yes or no? Now shifting of this hydrogen. This is the alpha hydrogen, shifting of that, it is nothing but hyperconjugation. See there? This hydrogen means it's not exactly about the hydrogen. We are taking alpha CH sigma electrons. This is the alpha. Now these electrons, not the hydrogen electrons, we are taking these electrons. Yes. See here carefully. CH like this. Now this is the alpha hydrogen. This CH alpha sigma electrons delocalization will take place. See in what way it is happening. See the bond clearly. These bonded electrons will shift here like this. Yes or no? This bonded electrons will shift like that here. Then this carbon is going to have the 5 bonds. These electrons will simply shift to. These electrons will shift to that carbon atom. Then what we can get from that structure? See here bonded, here hydrogen without bonding, it exists in the stays in the air like that. Now remaining structure is going to be double bond C minus H like that. SR. After that, again these electrons will be back. These electrons are taken, this one, again it is connected, and we'll get back the structure with what we have started. Yeah, Kumar Sai, good evening. Please try to understand, guys. Very, very important concept it is. Maybe it is a little bit tough to understand, but try to get that. And electrons are coming back and taking that, so that what structure we can get from that is, again the back structure. So like how many hydrogens are here? 3 hydrogens. So 3 are possible. So 3 hyperconjugated structures. Remember, number of hyperconjugated structures are equals to, yeah, see Monica, first of all these electrons, see here, these bonded electrons are shifting like this and forming the double bond. After that these electrons are shifting like this and forming the negative charge. Again the electrons are coming back and taking this hydrogen and get back the structure what we have started. This is what hyperconjugation. Here like that, how many are possible means, how many are there? 3 hydrogens are there. So 3 structures are possible. So you can take this formula, guys. Yeah, you'll get Kumar Sai, minimum 2 questions, 2 or 3 you will get. It's not 2 or 3 questions. To understand remaining organic chemistry, you need to know GOC properly. If not, you can't get it. Right. Number of hyperconjugated structures is equals to, number of hyperconjugated structures is equals to number of alpha hydrogens. So how many alpha hydrogens are there? That many structures we can write it. So here how many are there? 3 are there. So 3 are possible for the alpha. This is what hyperconjugation. Here we are removing sigma and already pi bond is there. What is vacant there? Pi star is vacant. So that's why this is called as sigma pi star overlapping. That kind of overlapping is happening. Now I am writing structure, guys. You tell me how many structures are possible for this and what kind of overlapping is this. You just tell me the 2 points. Almost Kumar Sai, mostly they'll ask in equal manner. Half of the questions from the first year, half of the questions from the second year. Mostly they'll maintain like that. Okay. Now tell me, guys, how many hypercon structures are possible here and what is the overlapping, type of overlapping is there? Yeah, sigma with what? Manjari. See there, what kind of overlapping? Sigma pi star, no? Yeah, in the same manner here, sigma with what? And how many hypercon structures are possible for that? Anyone? Remaining people? So we are removing sigma. So that's why this is sigma. With what it is getting connected? Sigma bond only removing, with the vacant p orbital of the carbon. Carbon vacant p orbital is there because carbon should be with 4 bonds, but here 3 bonds are there. 1 p is vacant. So this is sigma p overlapping. Very good, Manjari. How many are possible? 3 are possible because 3 alpha hydrogens are there. So number of hypercon structures are 3 for this. Because there are 3 hydrogen atoms. Got it? staggered and eclipsed both. Very good. Next, we can do this kind of question. Sometimes we have the reverse hyperconjugation, guys. That also you need to know. Just to have an idea about the reverse hyperconjugation. A reverse hyperconjugation. See in what way it will happen. See F and F and F. CH double bond CH2 like that. So these double bond electrons are coming here and forming the bond. These electrons are going off. So now it is becoming CF and F, it's becoming F minus, and here it is forming the double bond CH2 plus. This is what we can get. Now again these electrons are coming back, these electrons are taken by that, we'll get back this section back. Again. So this is called as reverse hyperconjugation because it has to give the electron cloud, but here it is taking reverse. Can you tell me what kind of overlapping it is? Here we are breaking pi bond, no. So that's why this is called as pi sigma star overlapping. Previous advanced question it is like what kind of overlapping is happening. First one I told no. This is the previous advanced question. Take care. Now we can have applications regarding this. We can say, guys, whichever is having more number of hyperconjugations, that is more stable, because to get more number of hyperconjugations, like electrons are like participate in the resonance more number of times. Because of resonance more number of times, it is going to lose more energy, more transfer of electrons. Further, it is going to lose more energy. Because of that, it will get the more stability. Yes, no? So it will become more stable by having more number of conjugations like that. So to get the stability, so whatever it is happening in the nature, the ultimate motto is to get the stability. So that's what it's happening here. To get the stability, it will participate in this way. Yes, no? Now, we'll see some questions related to this. Yeah, see guys. CH3 plus CH3, CH2 plus CH3, CH, CH3 plus yeah, fine. We have like this. Tell me what is the stability over there? Which is more stable in the 1, 2, 3, 4? These kind of questions we can expect for the MSET or mains or NEET. Which is more stable, which is less stable? Yeah, order Monica. Fine. What is the order? Manjari. No, Manjari. Yeah, Vani, fine. Good, Vani. So, stability order is we can say that 4 greater than, 3 greater than, 2 greater than 1. Because, see, how many hybrid conjugations are possible for this? Okay, fine, Manjari. Here, how many hybrid conjugations possible for this first structure? Anyone? First structure is having how many hyperconjugations? Yes, Vani, fine. How many are there for the first structure? Number of hyperconjugations are how many? First structure, first one. Yeah, for this we have 9 for first one. Okay. I'm asking for the first one, Vani. For the one, how many are possible? For the first one, how many are possible? For first one, Monica. No, wrong answer. I'm asking for the first one. You should know this clearly. How many hyperconjugate structures are possible for the first one? Vani, wrong answer. Monica, wrong answer for first one. Okay, tell me for the second one then. Yes, Monica, option one only. Adikesh, 10 now. For which one, man? I am asking number of hyperconjugate structures for the first one is. Wrong answer. See, there are no alpha hydrogens, no alpha carbons. So the first one is 0. Here carbon, this is the alpha carbon, 3 are there. For this 3. Here this is the alpha, this is the alpha. For this 6, for this 9. Monica, for the second option, oh Monica, you took the wrong answer. These hydrogens we should not consider. We should consider, that's what I am saying. We should consider only the alpha hydrogens, the hydrogens which are connected to the alpha carbon only. Please get that point. This CH2, these are not the alpha, that we should not take. We are taking only which are connected to this. Clear? Good. Now tell me for this, which is more stable? Very important questions. Just take it carefully, guys. First one I am giving again. CH2 double bond CH2. Second one. CH3 CH double bond CH2. Third one. CH3 CH3 double bond CH2. Fourth one. CH3 CH3 double bond CH3 CH. Fifth one. CH3 double bond CH3. Yeah, fine. Found money. Fine. Monica, okay. Now you decide which is more stable among these 5. I've already told you what kind of overlapping. Manjari, are you there or not? What kind of overlapping is there? Everything I told you. So according to that, you decide. And we know that stability can be decided based on the based on number of hyperconstructions. Because having more number of hyperconjugations, that is more stable. Yes, Vani. Very good. So stability order is 5 greater than 4, 3, 2, 1, like that. So how can we say in that manner? Means yes, sir? Yeah, tell me for the 5, how many hyperconjugations are possible? Yes, 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 good. For the 5th one, how many hyperconjugations are possible? Yeah, Naveen, understood? Very good, Manjari. 12 are possible. See there, how many alpha are present? 3, 6, 9, 12. So, yes, Manjari. For the 5th one, 12. For the 4th one, 9. For the 3rd one, 6. For the 2nd one, 3. For the first one, how many hyperconjugations are possible for the first one? So stability is more number of hyperconjugations are there, that is more stable. Based on number of hyperconjugations, we can decide more are hyperconjugations, more will be stability. Yeah, for the first one it is 0. That's it. That is the way of deciding the stability of molecule. So we can give that statement: more substituted molecules are more stable, more substituted alkenes are more stable. Based on that, we can say like that. Yes, sir? Very good mentioning. More number of hyperconjugations are there, that is more stable. Good, Monica, fine mentioning. Nice. That's what. Now, you tell me for this. If you give the right answer for this, then we'll move to the next concept after that. That's fine. Hyperconjugation. Yeah, among those 3, now you decide which is more stable. First one. Second one. And third one. Now guys, you decide how many hyperconjugations, which is more stable. Same. Again, we are talking about stability order is. Yes, Monica. Good. Yeah, very nice. 3 greater than 2 greater than 1. Now, apart from that, tell me how many hyperconjugations are there for the first one, second one, third one. Number of hyperconjugated structures are. How many are there? Yeah, good guys. Very good. Yeah, Monica for 1, 0. That's what Monica, wrong answer. Monica, wrong answer. Yeah, how many hyperconjugated structures are there for the first one, second one, and third one? No, Manjari for the first one. Okay, try. See, this is the double bond. This is alpha carbon, this is alpha carbon. There are CH2, CH2. So 4 are possible for this. Now alpha, 4 plus 3, 7 are possible for this. Alpha, 4, 7, 10. So 10 are possible for this. Yes, sir? Any doubts are there, you can ask, guys. Very good. Fine, Monica. So this is what hyperconjugation. Next concept we have like inductive effect. Okay. So inductive effect is nothing but induction like something. See, simply, I think you have idea about this. We have a carbon chain, some chlorine is attached to this. Now, chlorine will have the negative charge because of more electronegativity. So that's why you'll have the partial positive charge. This is having positive charge, it will take electron from the adjacent carbon. It will take electron from the adjacent carbon. This will take electron from the adjacent carbon. Like up to 4 carbon atoms, this effect will be there. This is called as inductive effect. This is inducting the charge, the positive charge on this. Yeah, Adikeshav, you check the alpha, double bond adjacent is alpha, this is alpha, this is alpha. Here CH2 is there, no, 4. Alpha, alpha, this is also alpha. Here CH3 it is 4 plus 3. Here alpha, alpha, alpha and alpha, 4 plus 3 plus 3, it's 10 total. Got clarity now? Yeah, this is what inductive effect is. So it is inducting a group which donate to the electron into the carbon chain, that is plus side. So all the plus side groups, we have to remember the list which are the, which can act as plus side groups. So remember, plus side groups will donate electron cloud. Plus side groups will donate electron cloud. Okay. Plus side groups will donate electron cloud, and minus side groups will withdraw the electron cloud to the carbon. Plus psi means it will donate, minus psi means it will withdraw. Okay, this is what, guys, remember the order always: mesomeric effect or resonance greater than hyperconjugation greater than inductive effect. This is the order. Resonance, hyperconjugation, mesomeric effect. This is the order, guys. Yeah, that's fine. Now we're going to see the last part of this one, acidic strength and basic strength. You listen carefully, guys. From the acidic strength and basic strength, you will get one question. And from remaining GOC part, one question. Total 2 questions will be there. But at least one question you will get surely. So listen carefully this acidic strength and basic strength. Surely you will get the one question. Esa, everyone okay with that? We're going to start the acidic and basic strength. Is it fine for all, or you will see any doubts? Okay. Fine, guys. Keep adding acidic strength. So we'll give in the manner of some factors. Simply you can understand, guys. So listen carefully. Like we'll do point by point. You just follow every point clearly. There we can understand stability of intermediates, everything. So we'll get more clarity. Now take it. First factor is size or bond dissociation energy. Okay. Before that, you just write one thing. To compare acidic strength, write this point, yes, very important. To compare acidic strength, compare the stability of conjugate base. To compare the acidic strength, compare the stability of conjugate base. If conjugate base is more stable, respect to acid is more acidic. If conjugate base is more stable, respect to acid is more acidic. To compare acidic strength, compare the stability of conjugate base. If conjugate base is more stable, respect to acid is more acidic. So that is the concept of acidic strength. So always we have to compare what extent conjugate base is more stable. If it is more stable, automatically respect to acid will become more stable. So always we need to compare that. Based on what we need to compare means we are taking the factors like maybe inductive effects, intermediates, based on all this we'll see. So we'll cover entire topic here. Listen carefully, guys. Surely you'll get one question, please. So the first factor is factors affecting acidic strength. Factors affecting acidic strength. The first one is size or bond dissociation energy. Alright, guys. So you can tell me size or bond dissociation energy, HI, HBr, HCl and HI. Guys, you decide which is more stable here. Yes, guys, we will tell which is more acidic. Based on the stability, we can decide the acidic. You think the stability, then you decide. You give me answer finally, which is more acidic there. Very good. So, yes, guys. HI greater than HBr greater than HCl greater than HI. Why like that means, after removal of the proton, what is the conjugate base? I minus for this, Br minus for that, Cl minus for this, and I minus. So here negative charge can effectively dispersed in a more space of iodine compared to fluorine. Fluorine can't be effectively that one. Yeah, fine. Sorry, guys. HF, from this we'll get the F minus. Yeah. That one unit of negative charge can effectively handle by the I minus compared to this one. So bond and dissociation energy is less. Bond dissociation energy less, that will become more acidic. When the size is more, that will become less acidic. Sorry, size is more means size differentiation. How to take it? HF similar size, HI size variation is more here compared to this one. So if size variation is more, acidic strength is more because the bond strength is less. If size variation is more, means simply we can break that bond, so that we'll get that simply. Clear for all? Yeah, sizes are similar, bond energy is more. Simply I'll tell you, the bond between an apple and apple, bond between apple and watermelon. Now you tell me which bond is more strong? Bond between apple and apple, bond between apple and watermelon, which bond is more strong? More stable means apple and apple because sizes are similar. When the sizes are similar, bond energy is more. Remember this point. So the next one, electronegativity. Second factor. Factor number 2 it is. I'm giving one more example, guys. Electronegativity. Based on these factors, we can decide acidic strength, basic strength. Very, very important. Listen carefully. So I'm taking this one, CH4, NH3, H2O, HF. Now, which is more stable? So here you can write this statement, guys. In a group, means top to bottom, acidic strength increases. Yeah, very good. See, HF, which is more acidic there? One minute, please. Yeah, now you decide which is more acidic. HF, no? So acidic strength is again we can take like yeah, H4 is less than NH3 less than H2O. So electronegativity is more, automatically acidic strength is more. Right at this point, if En is more, acidic strength is more. So in a period, write this statement also. In a period means guys left to right, acidic strength increases. In a group also acidic strength increases because of bond energy. In period also acidic strength increases because of electronegativity. Remember this point carefully. Either in a group or in period for hydrates, acidic strength increases. For hydrates, you remember that point. We should not wait for oxides also. Oxides different. Completed out. Good. Now take the next factor. I am giving 1 point, 1 factor, and 1 example, guys. Third one is inductive effect. Inductive effect. Now see, I'm taking like this. Okay, we'll go for yeah. CH3OH, C2H5OH, like isopropyl alcohol OH. Now you decide which is more stable. First one, sir, which is more acidic? In 1, 2, 3, which is more acidic? Yes, anyone? No. Yeah. One, which is more acidic? 2 is more acidic. Maunika, no. Remaining people? 1, 2, 3. Yes, guys. Acidic strength is 1 greater than 2 greater than 3. Why it is like this means, yeah, come to the basic concept. No, Lohit, please take this with more care. Surely we'll get the one question. Listen properly, you will get that. You need to check the conjugate base. See the main concept. To compare the acidic strength, need to compare stability of conjugate base. What is the conjugate base? For example, HCl is there. After removal of the proton, H plus plus Cl minus. That Cl minus is called a conjugate base. If this conjugate base is more stable, respective acid is more acidic. Because after removal of the proton, something is becoming more stable, then it can easily lose that proton. If it is not becoming unstable, then it can't easily lose that proton. So that's why remember the concept. After removal of the proton, if the conjugate base is more stable, respective acid is more acidic. That is the concept there. Now, in the same way, we are going like that. You check the conjugate base. After removal of this one, what is the conjugate base? CH3O minus. After removal of this one, what is the conjugate base? C2H5O minus. After removal of the proton, this is what the conjugate base. Now you decide which is more stable, first one or second one or third one. Yes, guys, tell me which is more stable. Anyone? So already see how to decide stability of carbanion. It's already negative charge, donating group. Already negative charge, more donating group. Already negative charge, more donating group. So remember organic mantra. Yesterday I told you, more charge, less stable, whatever the charge. Whether it is positive or negative. Daily you have to revise this organic mantra. So here O- is there, one small donating group. 1- is there, big donating group. Already negative charge, one more donating group makes more charge. When it is becoming more charge, automatically this will become unstable. If it is unstable, then if conjugate base is unstable, no, then it will become less acidic. So acidic strength is more for that. Very good morning. More charge, less stable. Yes, Manjari. Oh, you also. Good. So it's already negative charge, more donating group. Already negative charge with the more donating group makes more charge. It will become unstable. Guys, got the point now clearly? So acidic strength is like this. I hope you got the logic. Is it clear for all or not? Shall I give one more example? Are you okay with this? What is perfect? Up to we'll take 6:30, Monica. Are you in little hurry? Any urgency is there? What is perfect? Huh? Good. Yeah. Take one more example so that you'll get more clarity. Formic acid, acetic acid, like we can say this kind of thing. CH3, C, CH3, CHCOH. Which is more acidic? The first one or the second one or the third? Which is more acidic? Manjari, after removal of the proton, you check the conjugate base. For the conjugate base, more charge is there. The conditions are creating more charge, it will become unstable. If the conjugate base is unstable, respective acidity, acid is less acidic. If the conjugate base is more stable, respective acid is more acidic. That's the concept. Yes, sir? Manjari, understood? Now you decide among those three which is more acidic. If you get that concept first logic, simply you can decide whatever the concept it is. Yeah, who will give the answer, guys? Yes, give me the order. Adikeshav. Yeah, fine. Manjari, give me the answer then. Yes, very good, Manjari. That's it. See, after removal of the proton, what we're getting? Conjugate base CO minus, CH3 COO minus. For this also, CH3 CH3 CH COO minus. Already negative charge. This total is donating group. Already negative charge, one donating group. Already negative charge. It's not donating group. Less donation is there, making less charge. Less charge, more stable. This is more stable. So acidic strength is more for this one. 1 greater than 2 greater than 3. So this is the factor inductive effect in what way deciding acidic strength, guys. Got clarity now? Next factor, fourth one, we have seen size or bond dissociation energy, electronegativity, and the inductive effect. Fourth one is resonance, guys. How resonance will decide the acidic strength? Simply, have a look here. I'm giving only questions. From the questions, we'll get the concept. OH and ROH. Now you tell me which is more acidic. Yeah, Manjari, fine. Apply the same concept. So always we have to remember, if the conjugate base is more stable, respective acid is more acidic. That is the main concept. From that only just go. Yes, guys, who will give the answer for this? Anyone? Which is more acidic? This is called as a phenol. So you can simply come to know that in the phenols and alcohols, which are more acidic? Can you decide? Manjari, understand the concept properly, apply that properly. Anyone? In the phenols and alcohols, which are more acidic? Whatever many people are not responding, see how to apply the concept. From this, if we remove the proton, what we can get? After remove the proton, I am checking the conjugate base. Yes, Bonnie, very good. So this is the conjugate base O minus. Here, after remove the proton, this is what we can get. So here O minus is there. R is the donating group, it links the charge. O minus is there. This charge is getting diminished by the resonance like this. They will participate in the resonance. So charge is becoming less. Anyway, so less charge is becoming more stable. So that's why phenols are more acidic than the alcohols. After removal of the proton, conjugate base is becoming more stable due to the conjugation of phenoxide ion. So that's why phenols are becoming more acidic than the alcohols. Clear, guys? Yes, yes, Vani. Shall I give one more in the same way? Now you decide. This is also very, very important. I am taking phenol and an acid. Now you tell me which is more acidic. Phenols or acids, which is more acidic? So we have decided that in alcohols and phenols are more acidic. Now the next one, in acids and phenols, which are more acidic? Very good, Naveen. Right answer. Remaining people not responding. Esa. Yes, yes, very good. See, simply after removal of the proton, what we are getting? Get the concept properly. It's not about remembering. Acids are, that's okay, but why it is like that, we have to know. After removal of the proton, this is what we are getting, conjugate base. And here, what is the conjugate base? RC double bond O minus. Now, here resonance is there, here also resonance. In both cases, resonance are there, but this is called as equivalent resonance because in after resonance also there is no change in the structure. See there how we are getting, even after the resonance we are getting the same structure. So that's why this is called as equivalent resonance. Compared to the normal resonance, equivalent resonance is more stable. So that's why always acids are more acidic than the phenols. Clear, guys? Yeah, I'm giving entire acidic order. See, alcohols are less than water, less than phenols, less than acids. This is the entire acidic strength. Yes, sir. So you take this order properly. So here one small exception. In the alcohols and water, only methyl alcohol is more acid than the water, remaining all alcohols. Generally, that is the order. Okay. Now you decide fifth factor. Resonance is over now. Fifth factor is. So in the alcohols and water, only methyl alcohol is more acidic than the water. Remaining all alcohols are like for all alcohols are the same. Next one is aromaticity. Next factor. Aromaticity. Then how will decide the order? Acidic strength. Now see guys, I am giving these two compounds. You tell me which is more acidic. In these two, which is more acidic? So fifth factor based on aromaticity, we are going to decide now. SN1. Yes. Yeah, Mr. Adi. How can we say like that? Wrong answer, guys. Yeah, man, think properly. Which is more acidic? It's not benzene, and there is no benzene even. Yeah, see. After removal of the proton from this, yeah, see guys carefully. I'm writing one more time here. It is not the benzene, no. This is what it is, a 5-membered ring, and this is a 7-membered ring like this. So here, what is happening exactly means that's what it is. It's not clear, I'm writing, that's why. Still, it's not clear. Okay, I'm writing a little bit bigger one. Like that. Yeah, this is fine. Now, you just observe there, after removal of the proton, what is happening. So, if you remove proton from the sp3 carbon, this kind of structure will get double bond, negative charge. After removal of the proton from this, we're going to get this kind of structure. Negative charge here. Now, this is becoming aromatic because how many electrons are the total? 6 electrons, no? This is becoming anti-aromatic because 8 electrons are there. So, after removal of the proton, it is becoming aromatic. So, that's why it's ready to lose the proton because it's after removal of the proton is becoming more stable by getting aromaticity because aromaticity stabilizes like anything. So, the first one is more acidic than the second one. Try to get the concept clearly, guys. After removal of the proton, it is becoming more stable by getting aromaticity. So that's why it is eager to lose the proton. Yes, sir? This is about the aromaticity. Now, yeah, everyone understood? Any doubts that you can ask us? Take the next one, sixth factor. It is about the percentage of S character. Percentage of S character. We're going to see, guys. Percentage of S character. Yeah. See here, I'm taking this example. You try to give answer. CH3, CH3, alkane. CH2 double bond, CH2, alkene. CH triple bond, CH alkane. Now, which is more acidic? I've already told you this concept about the percentage of S character at the time of chemical bonding and periodic properties. Based on that, guys, you try to decide which is more acidic there. Very good body. So here percentage of S character, if you take carbon, what is the hybridization for this sp3? S character is 25%. Here sp2, S character is 33.33%. Here sp, S character is 50. So more is the S character, more will be the electronegativity. We already know that more is the electronegativity, more will be the acidic strength. Because see what is happening exactly, that also, for that also reason, if we remove the proton, what is happening? C minus is forming. That C minus charge can effectively diminish by the more S character, because more S is there, more nuclear charge, because S is more close to the nucleus. More S is there, more electronegativity. Because of that electronegativity, the charge is effectively diminished. Means it is making less charge. Automatically, that's becoming more stable. If it is more stable, respective acid is more acidic. Like that, we can decide. Clear, guys? Yes or no? Completed. Got the concept properly or not? Any doubts are there? Just ask. I'll repeat it. Clear, Vani? Very good. Come to the next factor, hydrogen bonding. Seventh one. Hydrogen bonding. Hydrogen bonding, guys. Now, you tell me in this two. This is orthonitrophenol and this is paranitrophenol. Which is more acidic, orthonitrophenol or paranitrophenol? Can you decide anyone? Which one is the more acidic one? Either ortho or para. Anyone, guys? So see there, here hydrogen bonding is there between this. Due to that hydrogen bonding attraction, that proton can't come out easily. So it will become less acidic compared to this one. So paranitrophenol is more acidic than the orthonitrophenol. Okay, so para is less acidic due to hydrogen bonding. So you don't feel like hydrogen bonding is there whether it is more acidic or less acidic. It's not like that. Hydrogen bonding is there. In what way it is affecting in the molecule, that will decide. Sometimes due to hydrogen bonding, it can become more stable. So it's not about hydrogen bonding. It's about in what way it is affecting. See, I'll give one more example. Because of hydrogen bonding, it's becoming more stable. See, guys. I think you know this kind of acid. COOH, COH. Anyone, do you know the name of this? And one more, COOH and COOH. Like that. Anyone? Yes. So here hydrogen bonding is there. Simply it will lose because of that. It will lose the proton. This is more acidic for the pK1. So because of hydrogen bonding, that is more acidic. In the previous case, because of hydrogen bonding, it is less acidic. So by hydrogen bonding, we can decide in what way it is affecting. Based on that, we can tell. Okay, that's what we need there. Hope you got the logic. Esther. Next, effect of vacant d orbitals. Eighth one. Effect of vacant d orbitals. Now, see guys, we are taking benzoic acid. And I am taking benzoic acid only with some methyl groups like that. Benzoic acid with this kind of groups. 1, 2, 3. Now you decide which is more acidic among those three. Same concept. After removal of the proton, we are getting negative charge species. That is called as conjugate base. If conjugate base is more stable, respective acid is more acidic. That is the concept. That's it. Assam. Vani, no, wrong answer. Anyone? Remaining people. No, 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 no. No, Manjari. Yeah, see. After removal of the proton, here we are getting the negative charge, negative charge, negative charge, negative charge. Now, carbon with the 3 methyl groups, silicon with 3 methyl groups. So these two are donating groups only. Anyway, so one is greater than. Next here, carbon is there. The 3 groups are donating. What extent of donation is there? Entire thing is donated to this one. The donation capability decreases because this methyl group donation is taken by the vacant d orbitals of the silicon. The silicon vacant d orbital will effectively accommodate some electron density of methyl groups. So entire electron density won't reach to that one because of that donation effect is less. Less donation with the negative charge means less charge, means more stable, so more acidic. So here donation effect is diminished because of vacant d orbital of silicon. That kind of effect is not there for the carbon. That's what it is, guys. Clear? Yes, Manjari, good. Now I am giving one more example. You just try to decide. Yeah, see there, Vani. These two are donating groups for B and C. The donation capability decreases, the donation capability of methyl groups decreases by the vacant d orbital of silicon. That kind of effect won't be there for the carbon. More donation is there. Donation effect is less because of vacant d orbitals. So that's why this is the second one is having more electron cloud. More electron cloud means more charge, less stable. So that's why less acidic. Now one more thing I'll tell you. In the same way, you try to decide, guys. See, methyl, CH2COOH. In the same way, first one, second one, methyl, CH2COOH. Now you tell which is more stable, first one or the second one, which is more acidic, sorry. Same concept. Yes, Vani. That's what it go wrong. After removal of proton, here the negative charge, here the negative charge. The negative charge can't diminish by the silicon because it's not connected directly to this carbon. Here, so there is no effect of d orbitals. Then we can go for electronegativity compared to carbon. Like compared to silicon, carbon is more electronegative. More is electronegative. So that's why first one is greater than second one. So here d orbital effect is not there because it's not directly connected to that carbon. In the middle, one more carbon is there. There is no resonance. There is only inductive effect. If it is inductive effect, we should take only the electronegativity through the sigma bond, not the pi bond. So that's why one is greater than two. So silicon is there. In what way it affecting is more important. Based on that only we can decide. Got clarity, guys? Yes or no? Okay, clear, Avani? Yeah, take the next factor. We can go for last one and very important. Mostly based on this only they're asking questions. Ortho effect. Yeah, listen clearly, guys. From this only we can get one question. Ortho effect. Now, if we take this one, we are taking the benzoic acid. We are taking like benzoic acid. Yes, benzoic acid. Here I kept a methyl group, CH3. Now you tell me which is more acidic. How to decide? Yes, guys, anyone? Yeah, generally we feel like generally one supposed to be more. No, no. We can get even in the advance also one question based on this only. And we can get one question surely in the NEET and MCET. For all this is useful, very, very useful as strength and basic strength. Actually, this is the donating group. After removal of this one, minus charge, donating group, no donating group. As we know, donating groups are unfavorable, then one should be more acidic. But this is the wrong answer. 2 is greater than 1. That is the answer. How to decide that? Actually, what we know, donating groups are unfavorable because after removal of the proton, we are getting the negative charge. The charge should get diminished. Because of that, it will become more stable. Then it become more acidic. That is the regular concept. But here it is reverse. How can we say 2 is more acidic than the 1? Even though there is a donating group. Yes, anyone? How it is possible? No. Meta, para, or what is that? It's not like that, Vani. No. Yeah, if we take one more example in the same way, now at least you try to tell benzoic acid. I'm taking one methyl here. Benzoic acid. I'm taking one ethyl here. Ethyl, C2H5. C2H5. Benzoic acid. I'm taking isopropyl. Benzoic acid, I am taking tertiary butyl. At least now you decide which is more acidic. Very, very important this concept is. Mostly from this factor they used to ask the questions because it's a little bit different it is. Anyone? Which is more acidic? Yeah, Manjari, good. So the answer is 1 is less than, 2 is less than, 3 is less than 4. Actually, donating groups are there. They're unpreferable, supposed to be less acidic. But here it is reverse. Yes, no, Manjari, no. That's what I'm saying. Answer supposed to be 1, but here it is not 1. It is 4. Even 2 is greater than 1. 3 is then that 4. Here also the concept is reversed. Why it is like that? Exactly what is happening in that? That is what are the effect. Yes, no? So any group is there at ortho position, their acidic strength is more. If the group is more bulky, acidic strength increases more. That one point you remember. The group is more bulky, acidic strength will be more. Yes, Manjari. This is a different peculiar condition for this. And 2-3 times they asked in the mains based on ortho effect only. They used to ask acidic strength only based on ortho effect. Now exactly why it is like that and what is ortho effect, that all things we'll see in the next class more clearly. Esa, you think why the order is changing, and it's supposed to be like this only, but why it is changing like that? You think like that, and you search for what is the effect. Tomorrow we'll see, and tomorrow we'll start the basic strength. So aesthetic strength and basic strength, listen carefully. So that's why I'm going very slowly for that. Surely you'll get the one question. Based on these two classes, you'll get the one question, guys. Take care about that. Acidic strength and basic strength. Then we'll start the alkynes, benzene, second year organic chemistry, next electrochemistry, solutions, coordination compounds, all this. Yes, sir. Okay, guys, please read that point and tell me tomorrow why the order is like that and what is the ortho effect. Very, very important it is. Okay, take care. So we'll meet in the next class. Until that, have a nice time. Thank you, guys. Bye.